Okay, let's jump right into this explainer. Today, we are unpacking a really fascinating microlesson published today, June 24th, 2026, by a developer named Ang. We're looking at a specific piece of their ongoing project, which is a console app called Access to eBook. Now, as the name kind of gives away, this application handles exporting content into various ebook formats. But today's focus is on what happens when they add support for a seemingly simple format, plain TXT. We're going to break down the exact logic and Haskell mechanics used to make this feature work, and it's just a fantastic look at how structured thinking solves some surprisingly hidden complexities.
Right off the bat, there's a fascinating paradox at the core of this project, and it's a question Ang actually asks right in the source text. But wait, isn't the input format also TXT? Honestly, it's a brilliant question. If your source material is already a plain text file, why on earth would a developer spend their valuable time writing code to convert a TXT file right back into a TXT file? On the surface, it sounds completely redundant, right? You might think, hey, just copy and paste the file and call it a day. But the reality of software development, and honestly just data in general, is rarely that cooperative. In fact, if you have ever tried copying text from a PDF and pasted it into a document, only to get a scrambled mess of strange symbols, yeah, then you've met this demon firsthand. The why behind that paradox basically comes down to a harsh reality: dirty input. As Eng points out, input text formats are usually incredibly messy. They are full of invisible errors, totally inconsistent line endings, bad encoding, and completely invalid characters. If you just grab that raw text and pass it straight through into an ebook generator, you are practically begging for broken formatting and inevitable application crashes. So our goal here is clean export TXT. We absolutely need pristine, normalized data for reliable software processing. We're talking consistent line endings, proper UTF-8 character encoding, and zero invalid characters. Basically, what we are really talking about here is a digital makeover. We are taking raw, unpredictable data and forcing it into a highly predictable, standardized mold.
So how do we actually get from that dirty input to the clean export? Well, the solution is what we'll call the AST makeover. AST stands for Abstract Syntax Tree. Now, rather than just trying to aggressively find and replace random text strings, which, by the way, is a total recipe for disaster, Ang's approach takes the raw document and parses it into an AST. Think of an AST as a highly organized structural blueprint of the text. By converting the text into this tree-like structure, it can be passed through a series of very specific filters and systematically transformed. It allows the program to actually understand the architectural structure of the document, rather than just seeing a chaotic, random jumble of letters and spaces.
This AST makeover relies on a very specific, rigorous workflow. Ang outlines a strict 3-step normalization sequence that absolutely has to happen before any actual formatting logic even begins. Step 1, we've got to normalize the line endings so the text behaves exactly the same whether you're opening it on a Windows machine, a Mac, or a Linux system. Step 2, we ensure strict UTF-8 character encoding. That's the universal standard that prevents those weird gibberish characters from popping up on your screen. And step 3, we brutally strip out any remaining invalid characters. This is essentially the heavy scrubbing phase. We have to get this foundation perfectly spotless because otherwise, literally everything we build on top of it is going to wobble.
Once that underlying text data is totally scrubbed and normalized, we move into the actual transformation phase. Here, the text is pushed through an assembly line of additional filters. We need to clean up the white space, meaning we fix those annoying accidental double spaces or weird tab indentations. We also need to actively reformat the paragraphs so they actually flow correctly in an ebook environment. And finally, we perform any additional text processing required by the Access to eBook application itself. This stuff really matters because for the end user reading a book on their Kindle or their tablet, even one stray indent or a missing paragraph break can completely ruin the entire reading experience. It's a highly deliberate assembly line, taking raw material and polishing it step by step until it absolutely shines.
Okay, so we've covered the theoretical workflow. Now let's actually look at how this makeover is achieved under the hood using Haskell programming. Ang introduces a specific function for this called generate_txt. Now, if you aren't perfectly fluent in Haskell syntax, do not sweat it. We aren't going to get bogged down in raw code strings today. Instead, we're going to focus on the elegant logic of how this function operates. Haskell is a functional programming language, which means, and this is the truly beautiful part, it excels at taking data, passing it through a series of pure functions, and returning a totally predictable output without causing any unexpected side effects. That makes it absolutely perfect for our AST makeover process.
The core mechanics of that generate_txt function are so fascinating. First off, it handles writing the file directly from our newly customized AST. But it also automatically prepends metadata to the text if none currently exists. And how does it do this so smoothly? By leveraging function composition. That's just a fancy way of saying it chains simple functions together into one continuous, seamless pipeline. So combining the newly generated metadata lines with the body text lines becomes incredibly straightforward. And to handle the body text itself, the code heavily relies on a concept called pattern matching, which honestly is one of my absolute favorite features in Haskell.
Let's define exactly what pattern matching means in this context. Ang uses a helper function called block-to-lines, and it utilizes this pattern matching feature. Think of pattern matching as an incredibly intelligent sorting mechanism. As the application traverses down that abstract syntax tree, it encounters all these different blocks of content. Pattern matching looks at a block, instantly checks its specific type, and determines the exact rule for how to extract the text from it. It's literally like a smart traffic cop, directing different types of data down different processing lanes to ensure everything ends up in exactly the right final format. To see this traffic cop in action, let's talk about how two specific AST elements are routed in Ang's code. When the pattern matcher identifies a block header, the assigned action is to extract that text and convert it directly into a strict text line, using a command called TL_to_strict. When it identifies a block paragraph, it does the exact same thing. It extracts it and converts it to a strict text line. By isolating each individual element of the tree and enforcing a strict conversion rule, the Haskell code ensures that no matter how chaotic or messy the original input was, the output is uniformly standardized into clean, strict text strings that the X2 app can safely use. Looking ahead, Ang leaves us with this sign-off. In the upcoming post, we will discuss the different normalization and transformation steps we will be adding to the exported TXT format. Today, we really just looked at the foundation. We learned exactly why we must convert TXT back into TXT, the sheer importance of that AST structure, and how Haskell's function composition and pattern matching make it possible to build a perfectly clean baseline. But as Ang hints right here, the real customized filtering is still to come. So to wrap up our explainer today, I want to leave you with this provocative thought to chew on. If a seemingly simple, ordinary text file requires this level of intense structural transformation just to function correctly, what hidden layers of chaos might be lurking in the data you interact with every single day, just waiting for a proper makeover?